welcome. Now let us proceed phreatic analysis of embankment dam or seepage through an embankment dam with two cases. Case one, if there is horizontal filter, which means horizontal drainage blanket. If you have, then what will happen? What will be the seepage discharge under the foundation of the embankment dam and also through the body of the dam. So this example, I think it is very nice and also an illustrative example to do other worksheet problems. So it says the cross-section of a medium earth dam is shown below. Locate the phreatic line, draw the flow net, and calculate the seepage or discharge passing through the body of the dam. So take hydraulic conductivity, which is K, 4 times 10 to the power of negative 6 meter per second. So to start with, let us see the free body diagram first. So you have the dimension of the embankment dam. You have bottom dimension, which is 142 meter, and filter dimension, which is horizontal filter at downstream top of the dam, 30 meter, and you have water depth 27 meter and freeboard 3 meter, top width 7 meter. So this is just the theoretical phreatic line. As you see, this is a theoretical phreatic line. Just it will join to the horizontal filter. So the main purpose of this horizontal filter is just to have safe exit of seepage water under the foundation of the dam. Otherwise, if you don't provide horizontal filter or drainage blanket, then it will be affected by piping. Then the dam may fail since it is an embankment dam. So this is a theoretical embankment, theoretical phreatic line for this embankment. So with this dimension, you have a parabola. Just this is a parabola curve. Now let us see. So this is the solution. You can see now. So you can see just the actual phreatic line starts at 0.3 times L of this length. So L means just the distance from the theoretical initiation of the theoretical seepage line up to the head of the dam. So this is L, then 0.3 L. It starts, then it will join. It will go like that, then it will touch the theoretical phreatic line, then it will go to the horizontal drainage blanket. So this is just a free body diagram for an embankment dam. Just the actual phreatic line, you have this dotted line, and the smooth line is just the theoretical phreatic line. So you have X and Y direction at this point. So the principal focus must be put on the initial point of the horizontal drainage blanket. So you have this, so you have parabola, so you have directrix. So this is directrix, a line which is parallel to the vertical axis, which is Y axis. So let us see. So the first step to do this problem is you have to calculate preliminary calculations such as just on upstream side, you have side slope, which is 1 vertical, 2.5 horizontal. So if you go 27 vertical, what will be the horizontal distance? So once you calculate by the slope, then you get, I think, 67.5 meter. Then step 2, location of A from B, which is this point, location of A, which is the actual phreatic line, it starts. So 0.3 times L, then you get 20.25. So you have water depth 27. Then next step, coordinate of A, which is B comma H. So B equal to 142 minus 30 minus 0.7 L. So this is this distance 0.7 L. So once you have 0.3 L, then 0.7 L. So if you multiply, you get, I think, this result, which is 64.75. So step 4, the coordinates of A, you can show now 64.75, 27, which is B comma H. So step 5, if you go to step 5 now, step 5, I think from property of parabola, which is PF, which means this one. So the distance from the principal focus to any point of the parabola curve is equal to from that point up to the directrix, which is PR. So PF is equal to PR according to property of parabola. So you have X and Y direction up to this point, point P. So you can see now this is a right angle triangle. So you can use Pythagoras theorem. then x square root of x square plus y square, which is pf. PR means x plus y. So once you have this equation, then you can square both sides. So after squaring both sides, you can get the equation of parabola, this equation, y is equal to 2x square root of 2x y naught plus y naught square. So if you substitute just for known values of coordinates of a, which is b comma h, x is equal to p and y is equal to h, then you get this value, which is y naught, the distance from this vertical axis up to the directrix, which is y naught. So you get 5.4. So the equation of the parabola is just if you square both sides, then you get this value. So step 7, I think, to locate the phreatic line using the equation, which is parabola equation. If you substitute y naught in place of this equation, then you get the square root of 10.8x plus 29.16. So locate the phreatic line, then you have coordinates for x 0, 10, 20 up to this value, up to b value. So it will go to b value. So this is b value. Up to b value you can plot later on. So this is just plotting. Now you can calculate now. So once you have this one, then for x0, y will be y naught, which is 5.4. Then 10, it will proceed like that. So you simply substitute the equation. So plotting. So plotting is just plotting of this parabola, which is this one. You can plot it. Then finally, I think phreatic line will be shown. So to draw the flow net, next step, the number of flow channel must be between 3 up to 6, and the number of equipotential drops shall not exceed 15. So this is according to the characteristics of flow net. So from characteristics of flow net, flow channel should not exceed 6, 3 to 6 you can take, and equipotential drops shall not exceed 15. So this is just, you can see now, this is just flow channel. One flow channel, delta Q, it will pass, delta Q, it will pass, delta Q. Total seepage discharge will be summation of all delta Q. So assume number of flow channel now, just 3, NF 3, and number of equipotential drops, ND 15. So once you have this, then you can just see now, you can see just by calculation, this is for isotropic soil, where Kx is equal to Ky is equal to Ka. You can use this equation where one single flow field, assume A square, B is equal to L, which is 1. Then you can use this equation for isotropic soil. So once you have this equation, you calculate. So 2.16 times 10 to the power of negative 5 meter cube per second per meter width of the dam. So this is for 1 meter width of the dam, which means like this. So this is 1 meter width. You have y depths, then you will substitute just multiplication. So direct solution using Darcy equation and continuity equation also, you can calculate seepage discharge. So velocity through porous media, is equal to K times I, hydraulic conductivity times hydraulic gradient. So where Q is equal to velocity times area, which is KIA. So in place of I, which is hydraulic gradient, which is the rate at which the depth is changing with respect to x, dy times over dx times area, y times 1. So this is y times 1. So this is a single just flow area. You can see a sample with this 1 meter width of the dam. Then you can just substitute. Then finally, if you derivate dy by dx, derivate this one, then I think you can get already. You can see from this proof. So once you have the derivative with respect to the function with respect to x, you can see 2y naught, x is 1, y naught is square 0. Then this is also, then cancel this to cancel ky naught. So you can use ky naught, which is direct solution for seepage discharge through the body of the dam per meter width of the dam. So k times y naught. So this is you can see the same result, 2.16 times 10 to the power of negative 5 meter cube per second per meter width of the dam. So this is just seepage discharge through 1 meter width of the dam. But if you have a length, which is if you have a length for example, if you have L length of crust, so seepage through the whole structure of the you can find Q. Already you calculate per meter width times crest length. So you get meter cube per second for the whole cross section of the dam. So this is case one. Case one, if there is horizontal filter. So I think this is case one. We will proceed to case two. So just to make clarification again, if you don't have top width or crest width of the embankment dam, you can use empirical equations. So top width for a medium dam, since this is just between 10 to 3, which is 27 plus 3, 30, then up to 30, you can use this equation for crest width. So sometimes you can use crest width, but for the time being, it is not required. Already you have bottom dimension and you can calculate B dimension since you have side slope upstream and downstream side slope. So sometimes bottom dimension, then please see these formulas again. So I think parabola, just properties of parabola. If you have xy coordinate, then if you have parabola, then the origin, which is the principal focus, so the principal focus up to any point of the curve of the parabola is equal to from that point up to the directrix. So a directrix is a line which is parallel to the vertical axis. So this is parabola curve. I think where f is principal focus. So with that approach, we have calculated y naught. Okay. Okay. So next method is if there is no horizontal filter or drainage blanket. For the same example, locate the phreatic line, draw the flow net, and also calculate the seepage or discharge passing through the body of the dam if there is no filter. So take hydraulic conductivity 4 times 10 to the power of -6. So this is, I think, just then you can see now step one, first step, just the same dimension you are using. So this is a theoretical phreatic line. Then it will touch the dam at that point, at J point. Then it will go tangentially up to the top of the dam. This is just step one. You can calculate now downstream slope 1 vertical to horizontal. Then if we go 30 vertical, what will be horizontal? 60 meter, 60 meter. So this one, then step 2, you go B dimension. So principal focus will be at the top of the dam. If there is no drainage blanket on the downstream side of the embankment. So B can be calculated 94, but in the previous one, 67.75. So this is just to show you a sample. Then step 3, you can go now, step 3. So this is inclination alpha, downstream inclination, tan inverse of 30 over 60, 30 meter height of the dam you have, then you can calculate. So once you calculate this, then you can get in degree measure 26.56 degree, which is downstream inclination angle. So you have theoretical phreatic line, but the actual phreatic line is 0.3 times L of this dimension. So it will go and it will join to the theoretical phreatic line. Then it will go downstream of the embankment dam. So for alpha less than 30 degree, you have this equation. So you can calculate using this equation, A, which is this one. A means this one, up to J. So you have Kj, Jf. So A plus delta A, you have Kf, this distance. So A means the tangent point or inflection point from J up to principal focus. So once you get this 18.88, then step 4, you go to step 4 now to locate the phreatic line using the parabola equation. Y is equal to square root of 2x y naught plus y naught square. So at x0, y will be y naught. So x varies from x a sine a cos alpha, which is 16.9, up to x is equal to b distance. So this means the curve starts onwards. So you will plot the curve from J onwards to the upstream side. So you will plot like that because this is tangent, which is a straight line. So you have triangle. You can put with this a dimension, a cos alpha and a sine alpha, the dimensions. Then similarly, y value a sine alpha 8.449 up to y is equal to 8 meter. So the curve starts from point J onwards. Similarly, for vertical and for horizontal. So you can calculate now the distance from the principal focus up to the directrix. Using this equation, you get this value, which is 3.772. So using the parabola equation, you can locate the phreatic line now. Phreatic line of an embankment dam, which is just x, you can put 0, then it starts from 16.9, which is this one, up to 94.75, which is B value. So you get for x0, you have y naught 3.772, then you proceed like that. So once you finish up to B distance, you get water depth, which is 27 meter. Up to 27 meter, you have to plot the curve. So plotting, simply you can plot this curve like this, then it will join to the tangent point, to the downstream toe of the dam. Okay, so finally, step 5, you can calculate now the discharge or seepage per meter width of the embankment dam using this equation. For alpha less than 30 degree, you have this equation. Then you can calculate 1.735 times 10 to the power of -5 meter cube per second per meter width of the dam. So you see, just observe now, with horizontal drainage blanket, you have 2.16 times 10 to the power of -5. But here you get 1.735. So it declines. So why this happens? Please justify. So this maybe as an assignment, you have to justify. So step 5, let us go to correction factor, which is shifting of theoretical phreatic line and actual phreatic line, which is this one. Kj is the shifting. Just the actual phreatic line, it will pass like this, it will meet, but this is actual phreatic line, it will go. The red one is actual and the blue one is theoretical. So this is delta A, which is the shifting point, the shifting distance. So you calculate now A plus delta A, which is Kf. You can use this equation. You get 35.72. Then delta A you can calculate now from this equation. Once you have A distance, and then you can get 16.84. So correction factor is computed using this equation. So you can check, then proceed. Then if there is any change, you can go back again and correct the inclination angle of the embankment dam. So I think 0.47134. So you go to the table, correction factor for alpha 30 degree, 0.36, for 60 degree, 0.32. So you proceed like that, then I think the value is just less than 30 degrees. So it is correct. Since we calculated the inclination angle 26.56 degree, which is less than 30 degree. So this is valid. So you can proceed with that. So the dimension you can proceed. So these are sample embankment dams photo. You can see just this is walkway. Then you have tower intake. Then if you have some inspection or maintenance, you go through walkway and enter to the intake tower, then you can maintain it. So you can see again, the spillway is separate. So you cannot construct spillway in the body of the dam. Since it is an embankment dam, erosion may be high, so separate spillway should be constructed for embankment. But for concrete gravity dam, spillway and other dam outlet structures can be incorporated in the body of the dam. Since it is concrete, if there is a flood emergency, no problem. You can open the gates. So this is an embankment dam, and this is also similarly upstream face is just treating with asphalt face, just to protect wave action and raindrop impacts. Okay, so I think these are examples for filter and without filter, with horizontal filter and with filter. So the first one is with horizontal filter, and the second example is without filter. So if you have any question, please contact with Telegram or e-learning. You can contact at any time. So I think once you have this, so you are kindly requested to do this example or exercise in your PowerPoint, which is cross-section of an embankment dam is given, so you can calculate. So please just try this example using that. And the second one is this one. Again, you have coordinates, which is y1, y2, y3, and y4. These are offsets for slices. For each slice you have, then you can try. Okay. Okay. So thank you. If you have any question, you are welcome. Okay, so this is all about today's tutorial. Hopefully you liked the video. If you have any comment or doubt regarding this topic, please let me know and write down in the comment section below. I will definitely reply on it. And thanks for watching.